This is the tutorial for taking models from Fusion 360 and turning them into toolpaths and things that you can actually carve out of the wood using the CNC Shark in the wood shop. So here's one of the final products of just a sample Napa High School model that I made in Fusion 360. You can see this is kind of an etched version where it's grooves on the letters and you have a little groove on this outside edge. And then the part is cut out of the actual wood itself. And there's a little chamfer on this these edges you can see right here. So that's one of them. Here's the second one I made, which is using the same model, but this is just using different toolpath settings. So this is a toolpath where instead of cutting in on the letters, it cuts around the letters, so it makes kind of like a negative of the letters. And it also does similar things on the edge. Does a full profile cut and everything. So I'll be going into Fusion 360 and show you all how that's done. So now we're in Fusion 360. This is the nameplate that I made. One thing you might notice is, compared to the final products I showed you, the holes aren't cut actually all the way through the wood. This is because the way that the software actually sees your models is, it sees the model just like this, but it's only going to cut things that it can actually cut. So you can set the depth of the cut, and also sometimes the depth of the cut is kind of predetermined by the width of your tool bit. So in this case, you can see on this narrow section of the H, if I inspect it and check the distance between these two lines, whoops, let me try one more time. If I inspect the distance between these two lines, you'll see it's a distance of 2.825 millimeters, which is about 0.111 inches. So that's less than 1/8 of an inch, and the smallest diameter bits we have are actually 1/8 of an inch. So you can't actually cut this all the way through using the bits we have unless you made that a bigger cut. So what you'll see in VCarve is that what it does is, for these areas, it cuts less deep. So if you look right here, this is using the V bit, the angled bit. So if you look, this trough right here is a lot deeper than the H trough right here, and that's just because, simply put, it can't go deep enough without widening this constriction. So you always have to keep stuff like that in mind when you're making Fusion 360 files. And the nice thing is, you can simply import the models and check by making the toolpaths and running the simulation like I showed you, and you can essentially just use that to see like what your output's going to be. So it's very useful to use this software just to see how they work. So let me go over, pretend you create a model like this. This is the model I created, Napa High School. It's a cool little logo, like kind of plaque thing. And you're probably wondering, how can I export this and put this into the actual VCarve software? So all you have to do is go here, export, name whatever you want. You go STL, you put whatever location you want. I have it going to a folder with my tutorial stuff. Hit export, and it'll actually start exporting right here. So I don't actually need to export this one. It finished really fast. Usually it takes a little bit longer, but that one's already done. And now we can move on to the step of actually like using this in VCarve. So that'll be part of this next step. Alright, so now we're in VCarve. I just did the, up here at the top left, I just did new, currently like in the setup for the material. So I talked about this in my past video on doing the bitmaps. You can choose whatever width and height you want. You can do this either one of two ways. You can make a kind of virtual piece of material that isn't actually going to be the piece of material you put in the on the bed of the machine. And that's kind of the way I prefer, but what you can actually do is just do the exact material you're going to put on the machine. So I'm not going to do that. I'm going to do a virtual piece, so I'm just going to say 5 by 5 inches. And then you can usually leave these things as default because that's just the way we do it here, and single-sided for job type. So now we just have our 2D plane that is going to be our material. It's 5 by 5 inches. And the first thing I'm going to do is go to modeling at this bottom, one of these bottom tabs down here. I'm going to go to import component or 3D model. I'm going to find that STL that I just used. So here's the one that I just used, NHS nameplate V5, and it imports it in. So this red box down here is actually that's your material. So that's the 3/8 thick 5 by 5 square of material. And you're probably wondering, why the heck is this thing so huge? That's simply because the computer thinks it's in millimeters, or it tried to convert everything to millimeters and then reinterpret it as inches. So an easy way just to switch this back is say scale millimeter to inches, and boom, just like that, that's the size we want. You say center model and it'll put it inside here for you. And then one thing to keep in mind is, I'm not sure why they do it like this, but this plane, this gray plane, is where the bottom of your material is going to be. It's kind of confusing because they put the red box around this to be your material, but the gray plane is where the bottom of your material is going to be. So if I were to say this right now, half of my model would actually get chopped off. So everything above that plane is what's actually going to get used. So what I'm going to do is, I'm going to change the slider right here to adjust that. So I can either do this, which would essentially make my model nothing because everything's below the plane, or I can do it the opposite, which is everything above the plane. Now everything's above the plane, I can actually save this, but I'm going to mention one more thing. If you need to rotate your object at all, you want like your object in a different orientation, you can use these buttons up here, or if you want to flip it on its side, anything like that, you can do that all from there. So that's just a little piece of advice. Adjust these again. Okay, now we're good to go. I'm going to save this, or click OK. And now my model is actually imported into the software, so I can do things to this model now that you know, I didn't have access to before. So the first thing you're always going to want to do is go to 2D view, go up here to, first you have to select the thing. If it gets darkened, that means you've selected this model, and then go to create vector boundary around selected components. Now you have a vector boundary, which essentially just draws lines on the edges that it sees. And this is useful for, you're going to need to use this outside line for a profile cut, and you can actually adjust the way that you're cutting this piece by using these vector boundaries. So let's go over the first way you can use this. If you just select your whole model and you don't select the model boundary at all, sorry, you don't select the vector boundaries at all, you can just select your model, go to the Toolpaths section, and just go straight into 3D finishing toolpath. So my material thickness is 3/8. It kind of gives you this stuff again. Since my material thickness is 3/8 and my object that I made in Fusion, you can see here, is also 3/8. So if I check from here to here, oh, that's going to be a little different because it has a chamfer at the top. Let me check on the inside edges. Here to here, boom, 3.375 inches. So they're both 3/8. So over here where it says gap above or gap below, these aren't relevant because they're both going to be 0. But if you have a model that's smaller than your material thickness, you can choose where you want that extra material to be. If you want to leave the extra material on the bottom of your piece, or you want it to be on top and get cut, you can choose that either way. So that's just something to keep in mind. Everything for here, you essentially just leave default, unless you plan on changing certain parameters. Oh, one thing I didn't mention is, since I'm treating this as a virtual piece, and this is an actual my piece of material, this big 5x5 inch box, I'm actually gonna move my my model to kind of be in a better spot. If you do in the 2D view, it's a little easier to get to match with the edges. I deleted my vector boundary because I should have done this earlier. So you double click, you can move this and it'll kind of snap to these edges a little bit. Snapping to the left edge. There you go. So I'm putting this in the bottom left because I'm gonna zero it from the bottom left. So I just want there to be as little material wasted as possible. Because if I were to print like 3 of these up on top of each other, you know, one here and then I did another one on top, I wouldn't have to worry about you know, the big chunks of material below the 0 that I'm wasting. So this way I can put in material that's longer than 5 inches, put clamps on corners, which would kind of be down here and down here, and then I could zero it to right here above the first clamp, and I could cut my piece and it'd be right where I expect it to be. So we're going to create the vector boundary again because I had to go back and do that step. And what we're going to do is, we're not going to do the vector one this first time, we're just going to select the model itself. So you click on just the model until it darkens. Then I'm going to go to model boundary, and this is a finishing machine toolpath, so this will be a nice looking toolpath. No like stair steppiness. And I'm going to use the V bit, which is the same one we used for etching in the bitmap tutorial. And boundary offset, this is always going to be half of the size of your bit. Unless you're doing really complicated things, you might have to adjust this, but for now, if we're doing like pretty plain, signage and stuff, I would stick to 0.25 or half of the size of your bit. So in my case, the bit up here is a 60-degree V bit, which looks like this shape right here, with the diameter of the largest diameter of the bit being ½ inch. So that means I divide ½ an inch by 2. I should get here 0.25. And also in here is where you can also, if you go to edit, the bit that you selected, you can change certain parameters of it. I would leave the defaults there because I've edited a lot of the bit sizes on the actual machine itself, so you shouldn't have to worry about that. Then we're going to go to calculate. This is going to take a while, so I'm going to pause the video and you'll just see it magically be done. Okay, and we're back. It's now done, so if I go back to Toolpaths, you can see it automatically comes up with the preview window, but I'll just show you as if it wasn't there. You just go here to preview Toolpaths, you click it, and the one I just did, which is 3D finish, I can now select it and say preview, select the toolpath. It'll take a sec, and now you see that what I cut was the essentially what I asked for in Fusion. So Fusion, I said, hey, make, I want grooves on the letters and I want a channel around it, and that's exactly what this has done. It's made a channel. Since it's using a V bit, it can't actually go all the way to the bottom, and I didn't ask it to go all the way to the bottom. I want it just to go deep enough so that it's kind of a nice sign. And you can see it looks pretty good all around. So now the next thing you have to do after doing that finishing pass for this one is you're gonna have to do a profile pass, and you can't just profile the whole thing or else it'll basically just dive the bit in everywhere and cut holes everywhere, but we don't want that. So we just want the piece cut out of the wood. So you're gonna select your vectors and right click on them, and you're gonna say ungroup objects back onto original layers. And then from here you can select one vector at a time. So you can either select this one, you can select any of them you want. I'm just gonna select the outside one because this is the one I actually want to use to cut out this sign from the entire piece of wood. So now I can go, I selected it again. Go back to Toolpaths, and this time I'm going to do a profile cut. This is called Profile Toolpath. Click on it. You select how deep you want it to be. I'm just making it the depth of the material. For the bit, I'm not going to use an 1/8 inch. I'm going to use a 1/4 inch end mill, which is a bit that looks like this. It's just a plain old bit that you it almost looks like a drill bit. I'm going to use that. You can choose how many passes. 4 passes should be fine to get through 3/8, because if you look here, the pass depth on this is 0.1, and that's fine. Usually you don't want a pass depth that's over half the size of, half the diameter of the bit. Half the diameter of a 1/4 inch bit would be 1/8. So this is under 1/8 because 1/8 is 0.125, so this is great. And you can choose to do outside, inside, or on. I'll show you what happens if I chose outside, because it might give you an unexpected result. See where it's cutting right now? Just keep that in mind. So I'm going to preview that selected toolpath, and that's exactly what we want. But you could also do it another way, where you say cut on that vector. So if I cut on the vector, now you see that line's moved in, and this is going to cut. This is kind of going to get rid of some of my chamfer on the outside edge. So I'm going to reset my preview. I'm going to run the first cut again. Takes a while. I'm going to run that second cut. And now you can see it actually got rid of my entire chamfer. So that's not really what I want, but this is another look you could go for if you enjoy that. Now we're gonna move on to the next kind of version of this signage. So I'm gonna go back. I'm gonna delete both of these toolpaths. Delete both those toolpaths, and again I'm gonna use these vectors, but this time I'm gonna select every single vector. So if I didn't ungroup these vectors, I could have just clicked on them and it would have highlighted them all, but since I ungrouped them, I have to go hold down shift and click each one of them to add it to my vector selection. And here I'm just going to do a VCarve engraving toolpath, because VCarve uses a vector, or sorry, the carves use vectors. The engraving use vectors, sorry, that's what I meant to say. I'm going to use the 60-degree ½ inch bit. I only want it to go an 1/8 inch deep at max. And then that's it. I'm just going to calculate this. Let's reset my preview, carve it. And now you see this is a different look. So this is kind of the negative of the letters. Instead of drilling the letters out, now it's drilling around the letters and letting the letters protrude up. So this is a cool look, and I like it actually a lot. So I kind of prefer this one over the other way. And then again, we're going to have to do the similar thing that we did last time because we need to cut this piece of wood out. So I'm going to select that outside vector. And using that, I'm going to do the profile toolpath. Click it, same 1/4 inch bit. Cut depth, I want it to go all the way through the material. The material is 0.375 inches thick. And I'm going to calculate this. So you'll see, actually let's go back and look at this. If you double click on them, you can go back and edit these toolpaths. So if you look at, where was it? Right here. So machine vectors, this is how it's going to cut on that line. So you can see right now it's actually going to cut right on the line. It's going to get rid of my chamfers. I want to keep those chamfers. So I'm going to say cut to the right. And that should make it cut out here. So let's see how that looks, because that might give us an unexpected result. So it did. This gave us like a trough, and that's not what I wanted. I don't want anything on the outside of this kind of line. So what I'm going to do is I'm going to go back here, and instead of cutting to the right of that that vector, the outside of the vector, I'm going to cut on it, and that means half the size of the bit is now going to be protruding in and cutting the material. So you can see the bit's going to cut on this line now, and depending on how wide the bit is, it's going to take material off over here. So I'm going to reset my preview again, do the first cut. I'm going to do this profile cut again. Boom, and that's kind of what I wanted. I do want the chamfer, so I'm going to go back in, and I'm going to add to the outside right, and then I'm going to use a 1/4 of the bit size. So since we're using a 1/4 inch end mill, half of that would be 1/8, and then a 1/4 of that would be 0.0625, which is a 16th. And I'm using negative because I want to offset it away from the actual model edge. So if we try this now, let me reset the preview. There we go. So now I've maintained my chamfer while also doing the profile cut, and you can see there's actually a little ledge. So I could offset this in a little bit more. So let's try 0.065. See how that looks. I could still go more. Let's try 0.0. Let's just try 0.07. Yeah, there's barely a ledge there now. There's not even a ledge on the front. It's a tiny one on the back. Let's go even more. Let's go 0.08. There we go. Now that cleaned up that little kind of cliff edge that we had. And now this thing's completely done. So as you see there, like, I had to go through a few iterations of just tweaking things until I got it perfectly right. And now it's perfect, and I don't have to worry about anything. So it definitely, the more time you spend in the software tweaking things to get it right, will save you time when you're actually machining it to get everything perfect. So that's that. That's it for that. And in the next video, I'll show you how you actually export these models, export these toolpaths to the machine so that you can cut these.